Haha, went early just to fool you. Okay, good morning. Right before the live stream, I grabbed my drink. Hang on, it looks like I'm frozen in that camera. I wonder if I'm working. Am I working? I don't know. Right. But just before the live stream, frozen. Can you hear me though? Yeah, okay, you can hear me. So, you can hear me. So this is, what are we going to say? Playing statues. All right. Just give me a second. I'm going to switch to a different camera. Okay. That's working off the side camera now. Hopefully that is working all right. I think the HDMI capture just freaked out right as I switched. But first, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And right before I got onto this, the cameras are in two different locations, so I'm thrown now. I've got to reorient myself. Right before I hit go live on the live stream, I took a swig of my drink and I was choking just as I hit start. Okay. Good morning, everybody, and welcome. Welcome to the stream. And as Mike says, good time zone appropriate time of day to you, to all of you who sail on the good ship. Yes, I think it was last time that Peter sent me messages that made my phone ding, and the messages were turn off notifications on your phone. So I've just done that. Good morning, John, Mr. XY, Sion, Chip, and Austin. We've got lots of people here today. Mitchell, Frank, Scott, Johnny, Mako. Oh, and the list goes on. This is cool. My glasses are fogging up. Why is that? I don't know. Okay. So, Mr. X, Mr. Y asked what squirrel we are going to chase. And there are a couple of things that we can go over today. A couple of interesting things. Peter says, I'm not here. Yeah. Peter sent me a message before the live stream apologizing that he wasn't going to be able to be here to remind me to eat lunch. So if Peter is not around at the end of the live stream, someone else has to be the honorary Peter and say, it's time to eat. Chris, g'day, Mike, Dodgy. Okay, so I am kind of tempted. I'm going to temporarily switch back to that camera. No, before I do, I'm going to turn off the capture device for it and turn it back on. Device off, turned it back on. This whole is very dodgy, right? Yeah, it just went laggy on this camera when I turned that back on. Replug the plug. All right, now I'm going to try switching to the front view and see if it's still frozen. Okay, we're on the front view. It looks, I'm getting like 2 frames a second. That's really bad. All right, I'm going to turn that front capture off. And hopefully it will all settle itself down. Oh, yes, you're right. Sound with as well, that's important, so I've got to leave that on. All right. Yeah, this whole thing right now that I'm using is a really dodgy setup. Okay, I'll just mention that before I get into the other things, because there are some topics to cover today. And so as you should know, I got the M1 Mac Mini a couple of weeks ago, so sound should be back now. And I got 3 27-inch monitors to work with it, and I had heaps of problems with them. The monitors themselves were really nice, but I couldn't get them to work properly with the USB-C to DisplayPort adapter. Yeah, dodgy streams are John. That's it. And after a little bit of back and forth with Dell, I ended up sending them back. So they've been taken back. Really lagging and no sound. That's strange because I'm seeing sound levels. Okay. Let me try switching back to that camera. Okay, I'm on the front camera, but this is the one that was causing the lag earlier. Back to the side camera. Yeah, okay. I'm going to stay on this one. This is just, it's the USB camera. And hopefully it's like the simplest thing it could do. All right, cool. So I ended up sending the monitors back and ordering, yes, at way more expense, a 49-inch super wide, but that hasn't arrived yet. So what I have at the moment is 2 temporary monitors and a whole bunch of dodgy stuff plugged into USB, including video capture. So I've got 3 HDMI capture devices going through 1 USB hub, which is horrible. So right now, the front camera and the audio capture is coming in on a USB hub. It's like a cobbled together with baling wire and bits of string sort of situation. But hopefully by next week, I will have the new monitor, which connects by Thunderbolt, and it exposes more USB ports, and I can clean all of this mess up, and it will all be, what's the term? Copacetic? Something like that. Yeah, lots of duct tape involved, Mitchell. Now, 2 things. I was going to dive straight into the Universal Rack Controller project, but just before that, oh, also, even I'm going to interrupt the interruption. I got a notification this morning on Facebook that it is 1 year since I did, you know, it's one of those 1 year ago things, and it said 1 year ago was when I did the live stream with the Party Poppers, which was for my 50th birthday, which is tomorrow, because last year it was on my birthday was on the Sunday of the live stream, and we were in lockdown V 2.0 at the time. So I did the Internet of Party Poppers live stream, and yeah, so tomorrow is 1 year since then, which means it's going to be it was a year ago, Andrew. So it's now lockdown V 5.0 here in Melbourne, and so I'm having my 51st birthday in lockdown as well. So I was thinking of setting up the Party Poppers. In fact, you can just see them. If you, right there at the very far end of that shelf, that little beige colored thing sticking down at it, which way? That way, at an odd angle. There. That is the end of the Party Popper board. And there is a bag of Party Poppers up there on the shelf ready to set it up again. So maybe I'll do that. The term is what? Cole Beceda. Oh, okay. No, we're not getting bombarded again today. But maybe I'll do it next week. Oh, but the other thing is, because it is my birthday tomorrow, that means that it is also time to wish happy birthday to someone else who is here in the chat. And I won't mention who, because disclosing personal information like other people's birthdays is probably not a great thing to do. But it is someone that I've known most of my life, since we were about, I think, would have been when we met, give or take. And no, it's not Sion. No, I've known Sion for a couple of years now, but no, there's someone else in the chat that I have known for 20, what am I saying? I've known for 35 years. That is amazing. I'm math good. Yeah, so anyway, to that person, I'm not going to out who it is. Happy birthday for almost the same day as mine. So, okay, so we finished the interruption of the interruption. Now back to the original interruption, which was going to be the UT61E project. And I'm just wondering what to show for that. No, I don't have anything out on the bench to show, but I'll just do a quick update on that because I assembled a few of those boards. A few people have bought them. We've got the very cool UI that that I showed, the Node Red UI that I showed on the live stream last week that Aaron has been doing. And what we are missing a very important piece right now. So the thing is that people have now bought those adapter boards to plug into their multimeters to get the data out of them. And right now what the firmware is doing is only reporting the raw packet. It is just reporting exactly what comes out of the multimeter, which is 14 bytes that will mean absolutely nothing to you if you just look at the packet. It needs to be processed to determine what mode the multimeter is in, where the decimal point needs to be, convert the the characters to actual digits so that you can get the value, etc. And so what we need is a decoder. Oh, Austin said, working on an over-the-air and built-in web interface as well for the UT61E. Awesome. That is very cool, Austin. Yeah, so the, let me see, what can I show you? So the major change is, and this is a thing that you'll probably be interested in. I will throw this up on the screen so you can see it. If I can go to, can I go to desktop sharing? Is this going to work? That is working. It's got the frozen picture, because, hang on, I'm just going to change the scene in here. So I'm going to turn off the HDMI front and I'm going to, you don't really need, hang on. This is what happens when I mess around with the OBS configuration live while I'm using it, which is not exactly ideal. All right, I'm going to stick this in here, stick that there, just so I can wave at you while I'm loading stuff up. Okay, in fact, what I should do is maybe stick that over there so that you can see what the URL is. Okay, this now makes more sense. Let's see, GitHub, and we want UT61E Wi-Fi. All right, so there are a couple of different aspects to this project. There is the board, and you have probably all seen the board. Let's do some browser zoomage to make it easier on the live stream. So the board connects to the optical interface that plugs into the multimeter, and it gives you USB out and also pumps out the data over Wi-Fi to MQTT. Now that is only part of it. The other part of it is what do you do with that data once it's been published. So what I've done is created a new folder in here called clients. And of course anyone is welcome to work on whatever. In fact, before we get to that, all right, clients, I'm going to back off a little bit. I've started making this document called protocol.md, which is still quite incomplete. But the idea here is to define how the firmware in the adapter reports the values from the multimeter so that people can then write clients that consume this data and display it. And that might be, for example, the Aaron's Node Red interface. He's also working on a desktop interface, like a standalone program. Or it could be something that takes it and sticks it into a database. Like you might want to connect a multimeter to a project where you're doing testing, like long-term testing. You might have an automated test jig with a multimeter plugged into it, and you want to read values over time, stick them all in a database, and then chart them. You know, there are lots of applications for this. So there could be a whole lot of different types of clients, and they could do different things. And the idea with this, by writing down the protocol here and just putting it in a simple format, it means that someone can write a client that will consume the data from the multimeter in whatever way they like. So this is it. Like, this is the whole document so far. It needs way more work, but I just put it in there as the start of a framework. And it at least shows the intention of where we are going with this. At the moment, the raw data packet is already being reported. And if you've got some software that can process the UT61E data, then you can consume that data and use it. And there are there are Python programs and things around that already do that. So these next two are the important bit, and this is really the next important stage in this project, is adding this to the firmware. So what I need to do is add a packet parser to the interface to the firmware for the device, so that it can report discrete values. And this part here, I'm really not sure of the best way to do this, and this is something that we can discuss, maybe talk about it in Discord. I've created a topic in Discord specifically for this project, and then what we can do is decide, for example, do we want to create a topic specifically for voltage, and a topic for current, and a topic for resistance, etc., and then just publish to those topics when we're in that mode? Or do you want a topic which is the value, and you publish to that topic regardless of what mode you're in, and have another topic that says what mode you're in? You know, there are different ways to approach this. And I'm kind of inclined to go for a separate topic for each type of reading, so that if you've got a device that wants to consume the data, and you only care about voltage readings, then you subscribe to the voltage topic, and you get that when it's in that mode. But maybe we need both. I'm open to suggestions, and I don't really know the best way to do that. So we need to figure that out. The other thing is the JSON message, and in some respects this kind of reflects back what we'll do with the discrete topics as well. So this is based on what Aaron has already done with his really cool looking little user interface. In fact, if I switch to is it overhead camera? Somewhere here. I can't remember. One of these I've got, oh, here it is, UT61E. Yeah, so this is the user interface which is being reported. Right now there's no value being displayed, obviously, but this is Aaron's little user interface, and it can be dragged out to different sizes or whatever. Super cool. And what he is doing is consuming a JSON message, and but his format is slightly different to this. This is how I think the format should be done. It is not how it is currently done. So in Aaron's code at the moment, he's got a field called value, and that is the magnitude of the current reading, regardless of whether it's a positive or negative value. So if you're reading minus 24.318 volts, the value field will just say 24.318, and then there is another field called negative, which will say true if it's negative. So the combination of those two fields is how you determine what the display should be showing, because the negative symbol in the user interface is simply set by this flag, true or false. And that's regardless of the value. And then the value is just displayed as a separate thing. So that makes sense in that context. But what I would prefer to do is keep that, but also have, but what I would do is change the value to abs value for absolute value. And that is that is what Aaron is currently reporting as value. And then the value field should be the actual value field, including the the sign. So that would say minus 24.318. And that sort of thing is much better if you're wanting to do stuff like take the value from the multimeter and stick it in a database, because you don't want to have extra logic in your client to look at the value and then look at the negative field and then multiply the value by -1 if the negative field is true. Like, that should just be unnecessary. You can do that, but it puts the burden on the client of having to do that logic every single time. Like, every client has to have that logic in it. So I think it makes sense to display the value including the sign and then report the absolute value and the sign as well. So that's how I've structured this example. But anyway, that is an ongoing and active thing. So now there was, what windows have I got open here? Where's the chat? That one? Must be that one. Yes. I lost the chat for a while. Okay. Value is a string for the interface. Yes, cool. So I hadn't even been able to see the chat while I've been talking about all of this. Yeah, so I just saw a comment by Aaron, then I lost it. Where was it? Oh, that's right. Okay, so yeah, well, value and abs values are strings, not actual numbers. Yeah. So what I've got written here, yes. I don't think, yeah, anyway. So that is a string, technically, yes. So I should change this in the value. What I should do is make this the type that it that it is in the message, but then in the description, I should say that what is contained in that is a float. So it's a string as far as the formatting of the message is concerned, but then what that string is containing or representing is a floating point value. But that's more a description of what it means rather than the format of the field, because it's not really a field. Yeah. Okay, so that's right. I got distracted from the distraction. So Aaron said, I've updated, just sending it to you now for review. Abs value should be a float, however the value is a string for the interface. Okay, cool. Thank you, Aaron, that is really cool. Yeah, so in getting back to this. All right, so I was talking about the protocol document. So we need to sort this out, and even before the thing is fully implemented. So what's happening at the moment is that Aaron is implementing the first client for this, and as part of that, we are feeling out the best way to structure the data so that it is useful from the client's point of view, and that's kind of guiding how the firmware is being developed. And then this is a way of capturing that. So this document that's on the screen right now is a way of capturing that so that when other people come along and they want to implement clients for this, they don't have to look at an existing client and try to reverse engineer it and figure out what fields are they reading and how are they using them, because that's the way you end up with like diverging or ambiguous situations. I'd like to have it defined here, like a list specifically of these are the fields that the firmware returns and these are what they mean. And then people can implement clients and feel confident that they're doing the right thing. So okay, so getting back to here, what I've done is created a clients folder, and of course anyone is free to create their own client, put it on their own GitHub repo, or whatever they want to do. Go for it, that would be fantastic. But as one place to collect some clients, I've made this folder called clients, and then I've made a folder called node red, and inside node red is Aaron's node red client, which is the one that I was just showing you. It is this one right here, and that kind of came about because Aaron sent it to me and just said, here, use this, and so I need somewhere, basically I needed somewhere to put it that it could be publicly accessed. So I just put it inside this repo. But don't feel any obligation to do that. If you want to, that would be great. What you can do is fork this project, work on your client, put it inside the client's directory, send me a pull request, and I'll merge it in. That would be really cool. Otherwise, just go for it in your own repo. So what I've done is made this folder called node red, because the way I envisage this is that we'll end up with folders for node red. I don't know, there might be Python, Rust, whatever the different environments are that the clients will be written in. And then inside node red, we've got this one, which is Aaron's web user interface client, but we might end up with another node red node in here, which might be log data to InfluxDB. Or we might have another one which does something totally different. I don't know. So we might end up with a few different things in here. And I need to add some installation instructions in here as well. It's got the configuration info in here coming from Aaron's instructions, but I need to add a little how to install in Node-RED guide. Yeah, so looking cool. Oh, wrong thing. I went back too far. Yeah, so the big thing right now is that in the firmware, it is not, cool. Put a photo, Austin just said, put a photo of the web interface on the Discord UT61 channel. Yes, I created the UT61 channel and then promptly ignored it. I haven't even looked in it. So then I need to get into there. Yes. Yeah, there are definitely valid reasons for reporting the value as the magnitude and the sign. Yes. I'm not saying that's a bad thing. There are definite situations where that makes sense because of the way it's going to be displayed. And in the case of like a multi-segment display, that can be a very valid method. And yeah, so that's why in this protocol, where was it? Back here. That's why in this protocol document, I want to support both. So report the value with the sign and report the value without the sign and the sign as a separate thing. And that way the client can use whichever is most useful. It doesn't need to mess around with doing its own logic unnecessarily. We can do that logic once in the firmware, report it in both ways, and everybody's happy. Okay, so yes. Yeah, so anyway, where do I go with that? The summary is that if you're interested in this UT61E Wi-Fi project, please come along to Discord. In fact, I will drop, no, not Discourse, it's on superhouse.tv Discord. I will drop this URL into the chat, and I'm doing and Johnny's got strong opinions about abs value should be the string. Well, I am very happy to be guided by what other people think. This is a little bit outside my area of expertise. I should say I don't have an area of expertise. I just make everything up as I go along. So for the people that work with things like JSON messaging on a regular basis and Node-RED and all those sorts of things that actually know what they are doing, I am very, very happy to follow advice. So come along to Discord and have a chat about it. That would be awesome. Now, that brings us to the next thing, which is the Universal Rack Controller project, because yeah, LSE. Oh, there's not much. LSE? Yes. I've slightly... Alright, this does... Yes, this I think bears some explanation because it sets the scene for what's going on with the Universal Rack Controller project. This will be like a getting up to speed thing for people that haven't been that familiar with the light switch controller project that has been going on for a really long time. So it began with the light switch controller. In the beginning, there what is it? In the beginning, there was darkness, or in the beginning there was void. I can't remember the quote. Anyway, and then we had the light switch controller. So there was my original light switch controller project from years ago, which was in the plastic case with modules and all sorts of hard wiring and stuff in it. And my goal since then has been to do a more streamlined version. And what you can see on the screen here, this picture, and in fact I have the physical thing right here. This is the same thing. The plan with this was to make a more tightly integrated light switch controller that was more like a product. And my ambition with this was really to make it like the sort of thing that if you went to a commercial home automation company and bought a proper commercial device, that would be the sort of quality that this project would be. It hasn't got there yet, but it's showing some good signs. So Johnny said, oh my god, it's not just a 3D render. No, it's not. Hang on, I'm going to switch. I'm going to switch to the front camera. Hopefully this will use the correct camera. No, it doesn't. All right, I'm going to change. You can probably still hear me, but just not see me. It looks frozen. So I'm going to change to that. Oh, yeah, side camera. Okay, that works all right. No, it is not just a 3D render. It's this. And this is actually kind of old. It's been around for a while now. I designed this metalwork in Fusion 360 and had it laser cut at a steel fabrication place just down the road in Bayswater. And this has in it, so this light switch controller board that is currently mounted in it was my first iteration of like the proper fully integrated thing. And the design has been revised a bit since then. You can see at this end it's got a pass-through for Ethernet. So on the front there is an Ethernet socket. Oops, right there. There's an Ethernet socket. On the inside there are two Ethernet sockets. In fact, let's do this properly. I've got an overhead camera for a reason. I should use it. Switch to there. Let's see if this overhead camera works. Yes! Cool. All right, now spin it around so that the angle makes sense. And yeah, so this board that's in here has a pass-through. So there is an Ethernet socket on the front panel, there is an Ethernet socket internally, and these are just connected directly back to back. There is nothing else between these. And the idea is that allows something like an Arduino or a Raspberry Pi or something to be mounted in here. And where's an example? Okay, so here's a Raspberry Pi. In fact, this Raspberry Pi has power over Ethernet support because it's got this hat on it. So what you could do, that's actually blue tacked in there. Yeah. This was all temporary mounts. So what you could do is mount a Raspberry Pi in there and connect from there I2C from this into here, and then that way you've got your network connection. It's powered over power over Ethernet, and it can talk to the front panel controller, and it can talk to all of the I/O ports. So we've got 24 sockets on here. Each socket has 4 digital lines for light switches plus power. So it's 96, potentially 96 light switches, like 96 buttons can be connected to this controller, although in only 24 locations because there's one cable coming out of each of these. So you can have 24 light switches like this. And they can have 1, 2, 3 or 4 buttons on them, but 24 locations with up to 4 buttons each. And these are illuminated buttons, and it just connects over Ethernet cable. Well, it's twisted, okay. The pedantic people will take me to task for that. It's twisted pair cable with AP8C connectors, which also happens to be used for Ethernet. And it's used just to link from the light switch back into the rack to the controller, and then that can be read by the Raspberry Pi or the Arduino, whatever it happens to be, and it can take action based on that, such as publishing to MQTT to turn lights on and off, all of that sort of thing. And what you can see down here, so this is where the whole, so what I'm giving you here is background that is going to lead into the Universal Rack Controller project. In fact, I'm gonna blue tack that in place just so that it doesn't flop around. Stay there. All right. Now what you can see up here is another PCB which contains a display and menu buttons. So these are little buttons that just protrude through through holes, and they do have caps that go on them, but I don't have the caps on them right now. So it's a little bit hard to see on camera, but because it's got, you can see large, what looks to you like large black buttons, they're actually holes, and then there are just the tops of tactile buttons poking through them. So this whole thing was modeled after the Cobalt rack that some of you may remember from back in the early 2000s, the little 1U rack mount web server. It had a character LCD here, like a green character LCD, and then it had these menu buttons, which is just up, down, left, right, and I think it was select and enter, or back and enter, or something. I can't even remember what these last two were, but it was like menu navigation. Yeah, so arrows essentially, and then things for selection. So you could use, what you could do is plug this into your network. I'm talking about the Cobalt. Plug it into your network, and then use this to go into setup mode. You could use left and right to select the digit in the IP address, and then up and down to increment or decrement the digit. So you could set the IP address entirely through this panel, and then enter to save it, and then it would be on your network. So potentially useful having a control panel here, but I am no longer convinced that it's required. I think this is just an extra complication for no real benefit when configuration can be done via the network. For example, it can just come up on DHCP by default, and then you can find it on your network and connect to it. Or over USB. You can plug a USB cable into it and then have a menu for configuration. So this, what you see here, this is what led to the concept of the Universal Rack Controller. Because what we see here is a number of elements of things that are in most projects. You need a microcontroller, particularly for home automation projects. You need a microcontroller, you need Ethernet or Wi-Fi, but basically networking. You need a power supply, and you need an enclosure, you know, the basic stuff. USB for configuration and loading firmware, whatever else you want to do. And what this is being used for right now is to build a light switch controller, and that's why it's got this in it. But if you took this away, the rest of this could be useful for building all sorts of projects. Like you could use this for building an audio distribution system, for example. You could have a boarding here which is a matrix of relays, or however else you want to do it, that switches multiple audio input sources to multiple audio output sources. So you'd have a matrix switcher in here and use that for controlling sound system through your house. Or it could be like, I've gone blank on who it is, but someone in Discord is using this to build, I think it might be James, a smoke detector control system. And that is a really cool idea. And there are a couple of other things as well. So it could be connections to security sensors. Like you could make a security, like a rack mount security system controller, or something to turn power on and off to things. Lots and lots of different options. So where the thinking went with this was, while I'm working on this, and there are things like, so this is the updated version. So what happened was, in working on this and talking to many other people about it, we came to the conclusion that what we should do is abstract away the common pieces of this project from the specific things, which in this case is the interface that talks to the light switches. So if you take this, what you see in front of you right now, and you delete everything that is under my hands, what you're left with is an enclosure, a microcontroller, a user interface, Ethernet, and power supply. And then you can put whatever you like in this part. And so that is why many months ago now, with the latest revisions to the light switch controller board, you can see this is the current version of the 24-port board. It lost everything that was on the left. It was trimmed down to just the light switch control portion, and the intention with that was to morph this project into being the universal rack controller. I'm not sure who came up with that name. It was someone on Discord said this is what it should be called. And so yeah, so the URC project is like a template or an empty framework for you to build whatever rack mount project you want into it. And so I'm kind of losing my train of thought on this, but yeah, so this is the light switch controller project, which many people have been excited about and pushing me to work on for a while. And these boards, so you can see here, I'll move this out of the way. This is a squirrel, it's not a squirrel. Where can I put it? Right there, you can see that. That's the 24-port version, there's a 16-port version, and there's the 8-port version. So these designs are done, essentially. They're finished. I've assembled them. Like, here's a bunch of the 16-port boards, not packaged yet, but these are fully tested and ready to go. And there's as you can see, the 8-port version and the 24-port version. Now, most of the time, the 24-port version is the one that makes sense, because this, having, say, 16 light switch locations is a little bit limiting. If you're going to put it into a rack mount case, which has got the room anyway, it makes sense to just put 24 ports in there. Even if you don't use them all initially, you can add things, because the extra ports can be used for other things, not necessarily just light switches. You could do things like connect motion detectors and have this detect movement around your house and act for both automation purposes and also for security purposes if you wanted to. You could have it trigger an alarm or something if it detects motion when it's in an armed state, that sort of thing. You could build your own security features around this, or you could attach different types of sensors to it. Detect smoke alarms being triggered or something, whatever. So in most situations, it makes sense just to stick in the 24-port breakout and not worry about the smaller ones. The smaller ones are kind of cool, and they allow you to build things up in a modular way. Yeah, but they'd be for more specific applications. So, this portion of it, apart from ongoing firmware work, and Ben and others have been doing fantastic work on the firmware that talks to these. The hardware from this point of view is done. So I am briefly putting these aside mentally. They are ready, so I'll stick those. I'll do a git stash on those and get back to this, because what this needs in order to be useful is all of the other stuff around it that goes in the rack. And the other stuff around it is the Universal Rack Controller project. So there have been other people working on similar things, and Josh Dennis has done some really interesting stuff as well. I'm just going to pull up a page, Dentistries. Now this will give you a reasonable concept. Sorry, I'll switch to the web view in just a moment. Desktop? Yep. So, what am I looking for? Rack hardware. So what Josh has done is design some boards kind of inspired by the light switch controller, I believe. And there are things like, so he's got things like the light switch link, which is, I think this is compatible. Yeah, it's got MCP 23017s, and yeah, but it's using, how many is on this? 12. Oh, 12, it's right there in the name. So that one supports 12 light switches, but it's basically the same architecture as the boards that I've done. What's this one? PoE Link 12. Yeah, this is something else that I've been thinking about doing, is making a version of this which is a PoE injector. And in this case, what he's done is put relays behind it. Let's just click on this so we can see it. So he's got relays behind it, which means you can power cycle any of the connected devices by firing the relay. So yeah, that's another application that could go into the same enclosure. In fact, with the same cutouts on the front and everything, it would be a direct drop-in replacement. And this, the rack unit controller, and this has Ethernet, USB, and power on the front. And then it's, I believe Josh based this on the Ether Mega design. So he took the Ether Mega and sort of stretched it around and moved it into a different structure. And so this has got an ATmega 2560 on it, and I/O breakouts, and power input, and all of that sort of stuff. And it's got a little footprint just there. Yeah, I don't think you can see it very clearly. There's a footprint just there that takes a Freetronics PoE adapter. So you could put one of my PoE regulators on here. It's got the same footprint as on an Ether Mega or Ether 10 and all of those sorts of things. So yeah, this unit here conceptually is a good example of what I'm talking about with making a board that you can use in a rack mount project that takes care of things like the Ethernet for you, and then you can build your own stuff into it. And so that leads us on to the, where are we? Get rid of Discord, get rid of that. Oh, and I should point out, so Dentistries, who is right here in the chat, is Josh. So Dodgy just asked, who is Josh? Josh is Dentistries. And yes, sorry, different names in different contexts. And I have a real problem with matching people's names up. Like often someone will tell me something in one context, and I'll know them by their Discord handle or something, and then I'll see their name in a different context, and I'll have no idea that it's the same person. Yeah, so. Oh, cool. So James said a few of my boards are on the Discord in the URC chat if you want to have a look. Yes, we're getting there, James. That's where we're heading with all of this. Now, I've kind of explained the background to you of what the URC is. Conceptually, it is a framework for building a project that can have different functionality depending on what you want. And so what I've done now is stepped away from the light switch controller boards in terms of the hardware. I think those are okay. And I'm looking now at the rest of this and the URC, so the Universal Rack Controller, and how to build the rest of this framework. And my original idea was basically what you can see there on the screen. It was very heavily inspired by the Cobalt rack. So it's got the 6 navigation buttons on the right. It's got the display just in here, which does things like show the IP address. So when you plug it in, it starts up, gets its address off DHCP, and then it shows the IP address on that display. So it means you can just look at it and go, oh, it is 192.blah, and you can log into its web interface or whatever. And Ethernet over here on the side, and then a spot in the middle for whatever you wanted to put in. And my original idea was simply to slice the PCB right through here, so separate out the Ethernet pass-through from the the project-specific part, and then build a new board that goes in here, which incorporates, and do 2 different versions. One which would be essentially what you see right there. It is just a board which is a pass-through. And then you can put whatever microcontroller you want in the back, Raspberry Pi. You could even put something like a Nano ITX PC motherboard in there if you wanted to. All sorts of possibilities. And then another version of the board which also has an ESP32 on it. So you could have Ethernet you could basically have all of the logic on that board, and then you don't need anything else in there except your I/O. So in the case of a light switch controller, what you'd end up with is a board here on the left, which takes Ethernet, and it would have the ESP32 on it with an I2C header, and you just you'd mount the breakout board in the middle, put a ribbon, like an IDC cable between the two, and you're done. That's it. Really simple. Or if you built a different board to go in the middle, put the same I2C header on it, plug it in, and you're done. And so that was what I was going to do, but I I thought that, well, this is the thing where the wisdom of the many can lead to a much better result than one person working on their own. And I decided that what I would do is put it out there to the Discord and get in everyone else's involvement and input and ideas. And of course, people are going to have different opinions on how this should be done. But the thing is that I can't necessarily think of all the different ways this project could be used. For example, it had never occurred to me to make a smoke detector controller. And it's not that that project needs anything really unusual, but that's just an example of the fact that I could build this empty project template with some of the infrastructure there for Ethernet and power, etc. But I wouldn't necessarily allow for all of the different use cases because I haven't thought of them. And another example is there is a board being developed which is it's a power distribution board, and it needs to be able to supply a significant amount of current, which means that if we had just, for example, a 2.1 millimeter DC jack as a power input, that's easy to do something like plug in a 12 volt 1 amp plug pack, or even like a 12 volt 2 amp plug pack. But pretty much beyond that, you start running into the limits of what that power socket can handle. And so we need some way of getting, in situations where you're building a project that needs a significant amount of power, which could be something like a lighting controller that's going to be driving LEDs directly. You might need many, many amps of power coming into the controller. We need some way of doing that. I wouldn't have thought of that because I haven't thought of those use cases, but all of this sort of stuff has come up in the Discord. So this is where, hang on, do I have Discord open? I do. Here, right here. Okay. Ooh, cool. I'm gonna have a I get to see some of James's ideas. But what I'm going to do is spin this back. So in fact, no, what I'll do is I'll show you in Keynote, I think, and then we'll get on to looking at James's concepts. So what I really like to do, I use Keynote as a tool for very quickly mocking up diagrams. I find it's a super useful thing. And what am I going to do? I'm going to make myself smaller because you don't need my big face blocking out what's visible on the screen there. And so what I started off with doing was taking my general idea and mocking it up as a representation of how it would all fit in the enclosure, and then posted this in Discord and asked for feedback. And this is where the really interesting discussion really kicked in and all the ideas started flowing, which is very, very cool. So what you can see here is my original idea. I think this might be the earliest slide that I did, like the earliest graphic I did. And what my concept was on the right-hand side, just here, is the light switch controller breakout. I was using this as an example of how how a project could use the universal rack controller. And then over on the left, I have a single board which incorporates a 240 by 240, I'll zoom it in, a 240 by 240 LCD, USB, either USB-C, or we'll get to that in a second, a power input jack, and a LAN port. And then the idea is that there could be two versions of this board that sits in here. The smart version, which incorporates the ESP32 and everything else, or a version that is just a simple pass-through. So you would have two connectors back to back, and then you would put a Raspberry Pi or something inside the case in here and use a jumper cable, just like I did in the prototype that I showed you on the bench. So this is where it was starting, and the whole point of this was to have discussion around issues like, what sort of USB connector should we have? Should we use USB-C connector? Should it be USB Type A? And I actually quite like the Type A's, the big square ones, for this sort of thing, because you can be kind of rough with them and you don't have to be all accurate when you're plugging them in. Like if you've got a laptop or something and you're standing in front of a rack holding a laptop in one arm and you've got a cable in one hand and you're trying to plug it into a device in the rack, with USB Type A, you can kind of just sort of shove it in and twist it and USB-D, and yeah, and get it into place easily. So the really old big square USB Type A, I'm kind of nostalgic for those because they were so simple, very strong and reliable. Type B, okay, the big square one is actually Type B, thanks Scott. Type A is the flat one, yes, and micro B is the one that is probably by far the most common at this point. So anyway, this was my original idea, and I thought, yeah, that seems pretty good, let's go with that. I'll just put it out there in case there are any other ideas. People have got opinions about sockets and that sort of thing, and whether a 2.1mm DC jack is adequate. And then the discussion started. Lots of people had ideas, and yeah, type A goes into the computer, type B goes into the peripheral. Yep. Thanks for that clarification. Correction, I was wrong in what I said. I'll just straight up say that. So I need to, in fact, let's fix this now. USB B. So this, okay, jumping between these two. These two are the same except for the different USB port. You can see it changing down there in the bottom left. And I was kind of flip-flopping. Where it all started was I thought this was kind of decided, and I was just flip-flopping between types of USB ports. And then the discussion began. And people have very strong opinions on things like which side the Ethernet port should be on, and where it should be relative to things like the display and other connectors. And so, yeah, we went through a whole lot of iterations. And, but yeah, as I was saying, I really like Keynote because it allows me to very quickly mock things up. So just as an example, like if I take a duplicate of this one, because I wanted to do a version where the, so this is meant to be a power LED, and I wanted to do a version where that was above the USB instead of above the Ethernet socket. Let's just group those together and then shift them over here. It's got snap alignment tools, so you can, oh, I can make that aligned with there, and I can vertically align it over there. Oh, excuse me. So yeah, I just find that Keynote is a fantastic tool, and I'm not that familiar with PowerPoint because I don't generally use Windows machines, but it's probably similar. But I find that the shapes, like the primitive shapes, and the snapping and everything in Keynote is fantastic for doing quick mock-ups like this. So yeah, things like these Ethernet sockets are made up of a couple of rectangles, and then it's all sitting on another rectangle, and then you can just group them and move them together, and you got yourself little things that actually look quite good. And so yeah, we had a discussion and went through a few different versions. So this is one of the things that came out of the discussions. I was mentioning earlier the power distribution unit as one application for this. And so the question went through, should we have something like pluggable screw terminals on the back to supplement the 2.1mm DC jack? And I personally really like XT60 connectors. I use them a lot. In fact, so I converted my bench power supplies. I've got my lab power supplies come down. If I switch to front, no, wrong one. I've got to go to side camera. Right here, so my lab power supplies come down to XT60 breakouts that are screwed on here to the bench, the underside of the bench. So what I can do is plug different things in. So here I've got, this is XT60 to alligator clips. So what I can do is just go, plug that in there, bench power supply. This is XT60 to 2.1mm DC jack. So if I want to power an Arduino, plug it in there, plug it in, and it's really convenient. So I'm a really big fan of XT60s. The reason that they are called XT60 is that they are rated, I can't remember if it's continuous or peak. I think they are rated to 60 amps of continuous current, and they peak somewhat higher than that. Or is it like 40 watts continuous peaking to 60? Something like that. But they are, yeah, they're really handy little connectors. I like them a lot. And they come in lead mounted versions, panel mounted versions, and PCB mounted versions. And there are bigger and smaller variations. There's XT30, XT90, XT120, and I've used all of them in different circumstances, including on the wheelchair motor controller. So the project that Chris and I did for LCA 2 LCAs ago, we built our own wheelchair motor controller. We had XT90 for the main power in feed, XT60 connectors going to the motors, and XT30 connectors going to the solenoids for the brakes. And they were all PCB mounted, with then flying leads going into them. So I'm a big fan of XT60. And so someone else in Discord also was talking about XT60. Who was it? Austin, might have been Austin. Austin's given a thumbs up to XT60. So what we discussed was, well, maybe what we could do is put an XT60 connector on the back here. It could be a panel mount connector. And then you've got an option of either using just a regular plug pack. It's really common for little projects like this to use something like a 12 volt plug pack with a 2.1mm DC jack in it and plug it in. And of course then there's a question of, do you want to power it from the back or do you want to power it from the front? So one thing you'll notice here is that in this mock-up there is no 2.1mm DC jack on the front of the panel. It's assumed that this device will either be powered over PoE via the LAN port or power coming in from the back, if it's going to be just connected to a plug pack or some other power source. And so that's kind of the way I prefer it. So this is where I'm converging on, at least. And yeah, so we had some discussion about power. And then there is a big discussion about the position of the Ethernet port. So what you can see down here, this is where it was Tinker who threw us for a 6. We'd been having this discussion for a few hours and we'd gone through a whole bunch of iterations, and I think we got to about this point and it seemed like this was something that most people were happy with. So Dodgy said, is the USB-C for power or data? Primarily for power, primarily for data, but there was also discussion about the possibility of using PD stuff, yeah, and debugging. So data and reflashing and possibly like a config menu or something like that, depending on what the device is that's inside this. So at the moment what we're doing is looking at this from the point of view of physically what connectors need to go on it and how should they be arranged. And we'll get back to that other stuff in just a moment. So I had been fixed on the idea of all of these ports being grouped together. So these things that you see down here. Now, if you look at the internal view, we've got the project specific section over on the right, and that is the thing that would be replaced by the power distribution unit board or the smoke detector management board or the security sensor interface board, or whatever it is. So this is the project specific part of it. And over on the left is the universal rack controller part of it. And that is one PCB that would have Ethernet, USB. You can see that the internal view is actually mismatched here. The ports are swapped. But it would have all of these on it. It would have the display, the microcontroller, etc. Now, so that, and in my mind, I was really fixed on the idea of these 3 ports being so these 3 ports on the front being physically close together because they have to be on the same PCB. And this is the point at which Tinker came along and threw the squirrel among the pigeons and said, how about you put the LAN port on the right? And then my first move was doing this. I simply took everything that was on the left side and I moved it to the right. exactly as it is. I did change the order, so you can see the it's got the LAN on this one. It's got the LAN towards the mounting tabs, and on this one, it's got the LAN towards the mounting tabs, and then shoved this across here, and then so I did this because I was still thinking in my head about having all of these ports, these things here, on this physical PCB, therefore they have to be in proximity to each other. And Tinker said, no, 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 keep the UI over on the left and just have the Ethernet on the right. And, oh yeah, the status LED away from the display. Yes, Intermittent Tech said, I changed the order of that though, move the status LED away from the display since you basically never want to look into both of them at the same time. Exactly, that was actually something that I said yesterday on the chat, and we are going to get a little bit closer to that as we get down there. So Dodgy said, partial to the left, partial to on the left, was there a reason for right? Yes, and that is because Tinker's job, I believe, is working with network gear. And the convention in a lot of that sort of situation is that you have LAN on the right and UI on the left. So don't apologize, Intermittent. That was a really good point you made. It's a very good observation. You were thinking ahead in terms of usability, and that's exactly why this sort of discussion is good, because it brings in different ideas and people will see things that I've missed. So what I did was threw it across to the other side. So I then split it. Anyway, so getting back to Dodgy's question, I was kind of partial to the left as well, because what I was thinking, if we go back to, I don't know, where one of these early, let's see, that one, one of these early-ish concepts, the way I was thinking of the cable routing for this is that the cable routing from the, if you're going to take the cable to the side to a cable management system and run it down the side of the rack, then you don't want to have the Ethernet pass, so, well, this connection here, pass in front of the display or USB-C or anything else. So in my head, what I was thinking was the cable would come out of the left side of the unit here, and it would actually go to the left into a cable, like a vertical cable management system. And these cables would go probably down into a patch bay or something, just with very short connections, or potentially go off to the right to a cable management system. And so Tinker pointed out that in rack setups, it's pretty common to have it so that Ethernet goes off to the right and user interface, like serial consoles and that sort of thing, are on the left. So I ended up splitting things around and doing this. Yeah, Mitchell says, yeah, info on the left, net on the right, kind of standard in the industry. Yep. And have a look at Ubuntu's equipment for a quick reference. Exactly. Yeah, and the Gen 2 Ubuntu, not Ubuntu, the Gen 2 Unify Ethernet switches are kind of an inspiration for me now. My inspiration has moved from the Cobalt rack to the Unify switches with the little display on it. They got a touchscreen display with augmented reality stuff and really cool things. But anyway, I like that sort of approach. So yeah, Scott said I even provided photographic proof. So yeah, yeah, and Scott is absolutely right. I was stuck in the way of thinking of it with this because I was trying desperately to keep everything grouped on this same PCB and come up with some arrangement where that would work. And when you separate the LAN from the info and the user interface, it causes a problem. Now, when Trung says, when can I buy this? Soon. Yes. So This thing is something that I got. Is that working? What's happened to that camera? Great. The overhead camera has frozen. I'm going to turn, let's see if I turn off the overhead camera. I'll be really happy to get past this dodgy USB. Now, is it working? Dodgy's correct. Dodgy said you can't buy it. John is going to tease us forever. Okay, so this cable, I bought these ages ago specifically for this project and this is a panel mount AP8C socket, so an Ethernet socket with a flying lead and a plug on the other end. And my idea with this was that where we have the LAN connection here on the PCB, instead of having a PCB, what we could do is take this socket and mount it in the panel, which unfortunately would require 2 screws through the front, but you know, that is what it is. And then we've got the flying lead and it plugs into the device that is inside. And you can see there that it directly replicates what I'm doing with my pass-through connectors here going to this. It's like a pre-made solution that isn't integrated with anything. So this thing, when we were talking about it on Discord yesterday, this thing is the first thing that came to my mind as a way to solve this problem. So going back to the desktop, I don't actually have a diagram to show you of that stage of the conversation. I think because I started editing and then I just kept going to the logical conclusion. Oh, Scott says, goodbye, stud welder. Yeah, attach it that way instead of having screws coming through the front panel. But it's okay, Scott. We've, I think, with all the iterating that we've been doing on this, we've got to a point where the solution is going to be really cool and really neat. And I really like where this has ended up. It's going to end up being much better than it would have been if I had just built what I was intending to build in the first place. So thanks for throwing the squirrel in with the pigeons. So in fact, I'll come down to, yeah, okay, I will get to those next ones in just a moment. Because we're converging on the end here. We're getting to the point of the can't use nutserts. Yes, I do that. Well, the thing is that damages the, you can't do that on the front panel neatly. I do that on the base. What I do is, in fact, that is how this is mounted. If I switch to, where am I? Overhead camera, is it going to work this time? Yes, it's working. Now you can see here, the thing is that there are 2 different things. There are nutserts and what's the other term? Clinch nuts, that's right. Oh, no, there are clinch nuts, riv nuts, and nutserts are the 3 different terms that people use. And there is some overlap and confusion about what refers to what. So what you can see in here, this thing in the back, it's a rivet with a thread through the middle. So a normal rivet, you put it into the riveting machine, poke it through the hole, you squeeze the handle, it pops the pin out of the middle, it flares it and it jams it in place. What this particular one does, so this is a riv nut. What this one does is there is a thread in the middle. So once you've popped it into place, that is now a mounting stake for, in this case, an M3 screw. And that is exactly how this whole board is mounted. There are riv nuts. So I drilled holes through the case, and then there are riv nuts here. You can see the silver backs of them. And you can also see others that have been, I did put in place because I originally had a Raspberry Pi mounted here with its front panel coming, with its front coming through this hole. And then I drilled out the rivets and pulled them back out again. But you can see that they form mounting stakes. They have some height to them. And then the PCB is screwed onto it or bolted onto it with M3 bolts. So that's riv nuts. Then there are clinch nuts and what's the other term? Yeah, I think clinch nuts is probably the more common thing. I won't bother pulling them out. I've got some in a box over there. I don't have them here that I can show you. But what you do with those is you drill a hole and then you sit it on top and put it into a press. So you need like a mechanical or a hydraulic press that exerts a lot of force down on top of it, and it pushes it into the hole and flares slightly, and then it is attached in place. Now the thing is that with riv nuts, they've got a flat on the back of them. So it actually protrudes from the through the case, and you can you can feel it. It forms a flat plate on the back, just like a rivet does. With clinch nuts, what they don't have that on the back, but they still have a hole and they still look ugly. So, and I've used those as well in another project. I use riv nuts in the wheelchair hand heater project. No, I use clinch nuts in the wheelchair hand heater project. Another option is to drill holes in it and thread the holes, but all of these reveal the connection on the other side of the metal. So this is really chasing a squirrel at the moment. I'll get back to the topic in a moment. So what would happen is that however this was attached, using any of those methods, unless it was something that was tack welded on the back, you would see on the face plate the fixing method, and I want to avoid that. But luckily we can avoid all of that. Okay. Nutserts, yes. That you put in a dimple hole. Riv nuts are the taper that you put in a dimpled hole. Yeah. So there are different variations. Okay. Luckily, we have a solution, I believe, that will work out neatly, and it solves Scott's goal, and it keeps the Ethernet over on the right and the info over on the left, and it doesn't require fastenings going through the front plate. It should all be very neat and very flexible and gives us options. So this is where this is going. Yes, okay, so this was the intermediate form before it morphed into its final form. We are almost there. And then we're going to have a quick look at James's things in Discord. So this was my immediate, this was my first pass at how to solve the problem of separating the display, having it over on the left and the Ethernet on the right, so that Scott could have the alignment that he wanted, and that honestly does make sense. This, if you're putting aside the whole problem of trying to keep the ports grouped together, if you ignore the internals and just look at the front panel, this is really the best way to do it. So ignore the issue with the status LED next to the LCD for now, but ignoring that, this is kind of the best from an exterior, what do we want the user experience to be like point of view. So I do like this. Alrighty. So this was my first pass, as I said. So what I was thinking, originally I thought I would use one of those patch cables, and I would, on the left hand side, we would have a board. So I don't have a sketch of this, I'm just going to describe how I got here. So I'd have a bigger board on the left, it would have the LCD on it, USB and Ethernet, and then what we would do is over on the right hand side we would have one of those little patch leads that I just showed you. It would be mounted to the front panel here somehow, it would come around and it would plug into the back of the board on the left. And so that was my first way of solving the problem of separating this out. So then I came up with this. This is still not quite the final form, but we're getting there. So then I came up with this, and I thought, instead of patching the Ethernet from the right to the left, why not patch USB from the left to the right? So what we've got here is two USB-C connectors that are back to back. And the idea is that this would be a little breakout board that would have the LCD on the front, it would have a USB-C connector on the front, and then this is just wired straight through. So what you would then do is have USB-C coming from here and then going into the board over on the right hand side, or going into a Raspberry Pi, or whatever you want. But then we still have the problem of how to get Ethernet to the Raspberry Pi if that's what you're going to do. So that brings us to, ta-da, this. Actually, what I'll do is go to this, because this is kind of a semi-minimal thing. And all right, I think this is pretty close to what we're actually going to build. It's in the ballpark. So what we've got is a board on the right hand side, which will have ESP32 on it. It's got an Ethernet socket and USB. So we've got USB to serial converter, and we've got power over Ethernet support in here. There is an I2C header on it just here. Power can optionally be sourced in from the back panel, either by the XT60 connector or the barrel jack. And so you can plug in Ethernet, you've got LAN, you've got connectivity for flashing, etc. And then a cable that goes from here, so this will be an SPI connection to the display mounted over on the far side. Yes, Johnny's right. So this makes Quindor happy. So the power LED is on the right hand side next to the LAN port and the USB socket, and the LCD is on its own over here on the left. Now this vertical view doesn't really show you very well what this would happen, but the way this would be mounted is the way I did the let's see if I can show you. I think the easiest way to show you, I can show you in Fusion 360, or I can show you here. I think this might be the easiest. So what we've got here, so you can see here we've got the LCD, we've got the buttons. What this requires is mounting a PCB directly behind the front panel without having any screws through the front panel. That was my whole goal with this. And the way I achieved it in this prototype was with the magic of 3D printing. So if we flip it over, in fact, I'm going to get some zoomage happening here on the overhead camera. Zoom which way? That way. So what we've got here, if we flip it over, there are two riv nuts that are mounted through the base of the enclosure. And then there are these two 3D printed brackets, and the PCB is mounted vertically behind the front panel with no screws going through the panel. And you can see that the brackets are screwed down into the riv nuts, and they provide the vertical mounting surface for the PCB. So my plan at this stage, it won't quite look like this because the shape is a little bit different, but to do something very similar to this idea, but mount only the LCD. And something like that is what would be at the left end here. So these grey things that you see here, maybe what I should do is, I'm going to make those blue so that it matches the 3D printing of the other prototype. So these would be brackets mounted through the bottom of the enclosure using riv nuts, and they would hold the display vertically directly behind the cutout in the front panel. So Akim said you could also have a pass-through terminal on the project-specific board so that you could have an arbitrary data from controller board to display board or whatever board you would connect on the left. Yeah, so, okay, good, good thoughts there. I think that ties into something that I'm going to talk about in just a moment, hopefully. What I'm looking for, I've actually got some of the displays right here. Let's flip this. I'm going to go back to overhead camera. So this is the display that I'm thinking of using. It's a 240 by 240 resolution, 1.3 inch color TFT with an SPI interface. And when it is mounted, so it's meant to be mounted, which way? That way. It's meant to be mounted like that, but it's actually square. So it kind of doesn't matter which way you mount it. The display is square, but the PCB is elongated with the connections along here. And it doesn't, I mean, it would be a tight fit. You could make it fit this way, but it's a tight fit. So what I'm thinking of doing is just mounting it horizontally and then just rotate in software. Make it a software problem. So, oh, the camera's slightly out of focus. I think I've got it zoomed in a little bit too far to focus at this point. So what will happen is that this will be mounted. You can see the mounting holes on here. So this will be attached to brackets that go inside. Where's a bare bit of it? Okay, so it'll go over on the left. It'll actually go somewhere approximately here. Mounted on the inside of the case like that, with a cutout about where the Superhouse logo is, so that the OLED is visible through it. And then what we need to do is get the connection, the electrical connection to it. And that is where, oh, Dodgy says, simple answer, to you. Yes. So what, I've got a display to go in that. You should see the display I wanted to put in this project. I just couldn't make it fit. So what we end up with is the display mounted in the left side. Oh, and another consideration here is I've been thinking about minimal intrusion into the inside of the case, so that when you're building a project in this, you need to have as much flexibility as possible. You don't want to be working around existing infrastructure. So the keeping this very low profile is important. And I think this is fairly minimal. It's going to be right up toward in one corner of the enclosure. It's going to be quite close to the front. It's not going to protrude into the back much. So if you wanted to put stuff behind it, there's plenty of room there. And all it needs is a cable. Now in this particular case, what I've shown is a cable which is routed just flat. So it comes out of the back of the here, it's folded over and it's routed flat straight across the front of the enclosure. It doesn't have to be. That cable could come up and around the back and then, you know, down here somewhere. But this was just the easiest way of representing it. And it may actually work out to be quite practical, depending on where the mounting holes are for the board that goes in here. You can just run underneath the board. So what you're looking at there is the URC project with the smart controller in it that does Ethernet and everything else. So this would have, so this connector here would be an I2C interface. This connector here is for the display, and then whatever other I/O is available on the ESP32 that isn't used, I would just expose it in here so that you could use it for your own project. So this is the empty canvas for you to paint your masterpiece on, and put your boards in here and expose connectors on the front here, do whatever else you like. Okay, so just as an example of that, one example application of that is this. So this is the template URC project, and then if you put in the light switch controller breakout, it becomes this. So, and you can see here, I mean, this, none of this is proportional. I've just eyeballed all of the dimensions of this. But the general idea is that with the mounting holes here, the cable for the display could just pass underneath whatever board is mounted in the middle and then come up here and connect onto the controller. and then the board that goes, not that one. So flipping between these two, I should have changed the color on this as well. I'm going to do that right now, just because it annoys me. And on this one, I'm going to change the color on these little 3D printed brackets. Okay, so now when I flip between them, those don't change color. So, all right, so this is it built as a light switch controller. And, oh, Scott said, now just make sure that space will fit 4 8-port LSCs. I think that might be squashing it a little bit, but let's see what we can manage. So the goal is, with that respect, in terms of space, keep this display over on the left, and I want to cut this with, just very slightly rounded corners. So this is going to be quite reminiscent of a Unify Ethernet switch in terms of the way that looks, except that it won't be a touchscreen. And if we keep this on the right hand side across to as far to the right as we can. Oh yeah, and Austin points out, FYI folks, the 3x8 ports doesn't fit the same space as the 24 port. Yeah, and I'll actually show you that in a moment, exactly why that is. So this left edge here, keep this as far across to the right as possible, possibly at the extent of making it longer. Like this particular board, I would be very happy making this quite deep as long as it's narrow. So when it actually comes time to lay out the PCB, in fact, I've got the schematic for this in Eagle. I can show you that as well. So when it comes time to lay out this PCB, I'm going to make this narrow and deep so that it leaves as much space in the middle here as possible for whatever project needs to go in there. Austin says, added a photo idea for the SPI cable connection to Discord. Cool. This is exactly what I'm hoping for, is that there are so many people providing input to this project, and that just makes it better. Yeah, so what you're looking at right there, I think, is going to be extremely close to how the light switch controller is finally going to turn out. So what that that front panel looks like there is pretty much what the upcoming light switch controller will be. And this is kind of the layout. Now, Dodgy said, have buttons been flicked? That's a good point. I'll get back to that, I think. Or should I talk about it now? No, I'll get back to that. So I need to, I should write notes to myself. So I need to talk about fitting 3x8 ports and buttons. All right, drink time. Okay, so I will try to remember to talk about both those things. Now, where am I going from here? Okay, so this is it applied as a light switch controller. This is it applied just as a template, so that you can build whatever you want in the middle here. And there's been some discussion on the Discord as well about standardizing mounting holes for whatever goes in here. And the mounting holes for the light switch controller board have kind of been dictated by the position of these connectors and putting screws in between them. So what I think would be a good idea would be maybe extending this and making it kind of like a grid, perhaps, I don't know. And yeah, and then having all of the mechanicals for this nicely defined. Now, of course, you can drill whatever holes you like in this. You could, Andrew asked a very good question, which is, what is the current depth of the case? Undecided right now. That's a very good point. I would like to keep it shallow, but it needs to be deep enough to, because the thing is that in both of my racks, I've got rack enclosures that are mounted in cupboard spaces, and they're not very deep. So things like Ethernet switches and things fit in fine, but there's no way I could fit in something like a 1U rack mount server. I do have two, I've actually got two 42U full depth racks in my garage, but my home automation gear is in these cupboard mounted racks. So I'd like to keep it to within, basically make the dimensions similar to, like a Unify switch. So maybe 200 mils deep, 250, something in that region. I don't want to make it any deeper than is necessary. Oh, James says 350. That's really deep. I don't think it needs to be that deep, unless you want to put a whole lot of stuff in there. Yeah, about 200 millimeters. That's good. Yeah. Now, where was I? I've distracted myself, I think. So yeah, that's the application. That's right. So we're talking about mounting holes. So if ultimately I produce this as a product that people can buy as a starting point to build their own projects, there are a couple of things that they will need to do. One is mounting their boards, and the other is front panel cutouts to suit whatever needs to be done. And so that to some extent also determines the material. I don't want to chase that particular squirrel right now. That one that I was showing you on the camera a moment ago, that's steel, and it's really, really strong. It's probably thicker than it needs to be, because when I designed and ordered that, I didn't really have a sense of how strong it needed to be. So I ordered like a standard steel gauge, thinking, oh yeah, that'll be about right. And it turns out that it was thicker than it needed to be. So it's really heavy, really strong, but it is also really, really hard to work with for doing things. You can drill holes in it, no problem, but things like cutting out rectangular slots for connectors, like RJ45 connectors, that is a total pain, because you got to use something like a panel nibbling tool, and it's really, really hard. I ended up with, so that particular prototype, I had it laser cut. The overall shape of it was laser cut, but none of these holes in the front were cut. I just got it done as a blank. It was a totally blank front, and I then had to do all of this myself. So I drilled holes on the drill press and then used a panel nibbling tool and chopped it out, and I ended up with blisters, and it was a total pain. It was horrible to do that. So what I'm going to do, of course, is once this is done as the universal rack controller, then things like the cutouts for the LCD and the Ethernet will all be done by the laser cutter, but then the middle portion will need to be customizable. And so I'm thinking of using aluminium mostly for that reason, to just make it easy for people to rework it and customize it to suit their needs. So yeah, the production version of this is probably going to be aluminium, but the actual shape of this and whether the mounting tabs are separate or whether they are part of the front panel, that is a whole other discussion that is going to come. That will come. Oh yeah, there was a question there about pricing. Graham said, what kind of pricing were you looking at to get the metal laser cut? I actually can't remember. It was in the order of a few $100s to get 10 of them made, but I can't remember the actual number. It might have been like $300 to make 10, give or take. But keep in mind that the actual production version of this is going to cost a lot more, because that is just this is a really simple folded piece of metal. I'm going to zoom that camera back out because you need to be able to, wrong way, you need to be able to see the overall shape. And eventually the camera will stop shaking. So there are no sides on it. It's got these little tabs. I designed it so the sides would fold up as tabs just to give it rigidity, to stop the back of it flopping around. But there's no back on it, there's no cover. It is just a single piece that has been laser cut and then CNC folded. So the final production thing is going to need to have sides and a back and a cover, and it's going to be a much more complex design than this. And I'm thinking possibly detachable ears instead of having the ears as being part of the front panel, but I'm undecided on that. So yeah, the cost of the case could be not insignificant. All right, so back to here. Mounting. Anyway, some standardized mounting holes would be good for people who want to use the mounting holes. And if you want to do your own mounting holes, of course, you can drill your own mounting holes. There's no problem with that. Okay. Yeah, so Jordan said maybe laser cut, half depth laser cuts for 4 Ethernet blocks in the middle. Interesting idea, laser cut half depth. I hadn't even really thought about half depth laser cuts. I suppose that's a thing. Yeah, but what I will probably do, for me personally, the primary application of this is going to be the light switch controller. So what I'm going to do is have the metal work done in 2 versions. One version with all of the holes cut out for the light switch controller for the 24 port breakout, and the other one blank as a template. And then ultimately I might get other variations made. So what you see here is the template that you would end up with as the starting point for your project. But there's another variation on this. So this version has the smart universal rack controller board here on the right, which, as I said, will have Ethernet, USB, PoE, I/O breakouts, all of that sort of thing, power coming in from there. But what if you don't want to use this? What if you want to put a Nano ITX motherboard in here, or put a Raspberry Pi in here, or put whatever else you wanted to? And so the other way of doing that is this. So this is an example. In fact, what I'll do is right now, while we're here, I'm going to take this and I'll get rid of that. What else will I leave? Yeah, that'll do. I'll no, I will delete this, because this kind of represents what you would get with it. Delete that, delete that. Okay, so this is a representation of a version that just has a pass-through board down here on the right. So in terms of the front panel, if you look at the front panel on that, the front panel on that, they look exactly the same. It's got the same display in it, same Ethernet port, same USB-C connector. But instead of having the smart rack controller board down here on the right, it has a simpler board, which is much smaller, and it is just pass-through for LAN and USB-C. So 2 USB-C connectors wired back-to-back, 2 AP8C connectors wired back-to-back, and then you can put anything you like in the middle here. There's the SPI connection exposed here for the display, so you can connect that to your board and control it however you want. And then, for example, so this is why I just duplicated and edited this project. This is an example of doing that with a Raspberry Pi mounted in here. So you would use a little Ethernet patch cable to patch in network, and you use USB cable to plug in USB here. There could be a Pi hat on this, which takes power in from here. You could do PoE, you could do an SPI connection here to the display. So what I would probably do as a follow-up to this is design a Raspberry Pi hat that goes in here, and it takes care of this sort of thing. So if you wanted to build a project in here that had a Raspberry Pi and something else of your own, there would be a hat that would take care of the power connections, the PoE, and the interface to the display. Yeah, so Mitchell said, might be an idea for this if you cut a full rectangle from the front panel and you get effectively inserts for each project. Yeah, that was discussed on the Discord yesterday as a possibility. So, so what we could do is, yeah, I could maybe make that available as like a third version, but I'm not, for some reason, I'm not a huge fan of this idea. I don't really know why, but if we take, well, let's just make that gray. All right, so this is kind of what it would look like. So we would have the fixed infrastructure. So we've got the boards there and the display there, and then just a big rectangular cutout right through the middle here for you to put whatever you want in here. So whatever goes on the inside here, you could expose it through this cutout, and then you could 3D print a bezel, or you could laser cut a bezel. You could carve one out of wood. You can do whatever you like. But the idea is that you would then put whatever you want into this hole to make it neat, make it look neat with whatever you've put on the inside here. So this idea has been brought up a few times. Personally, I don't like the idea of the 3D printed or whatever bezel in here. I think it will end up looking kind of ugly compared to cutting specific holes to match the connectors that you want. But enough people have brought it up that I think it's probably worthwhile doing. So let me, so this is what I do when I'm messing around in Keynote. I just keep duplicating slides and keep editing them. All right, so this is the blank version, and this is the cutout version that you could then put, aha, long flare, 8 minutes to lunch. So you are the honorary Peter for today. Thanks, Chip. Yeah, so, yeah, anyway, my point was, for me, I don't think I would use it in this way. But enough people have mentioned this that I think it's worth doing, because this project is not all about me. It's the whole point of doing this and getting all of this input is being able to structure this in a way that makes sense for other people as well. So if having a version with a big cutout in the middle is something that appeals to people, then sure. Cable Tie said, "Where is Peter?" He was doing some other stuff. Yeah. You probably won't mind me saying I try not to reveal personal stuff, no matter how innocuous it is. I try not to reveal personal stuff. He's not doing anything exciting. It's just something that he had to do today, and which meant that he couldn't be here at the live stream. Yes. Cool. So, all right. I think I need to make 3 versions of the metalwork. Version with cutout, version with blank, and version with the holes specifically for the light switch controller. Because for me, the light switch controller is the one I care about. Yeah, so Aaron says, why not just make the entire front fascia interchangeable so the case, lid and rack ears are one parts and the fascia is interchangeable for the variants? Yes, exactly. That is, so earlier I said that there was a discussion that I kind of didn't want to get into just yet. Yes, that is the kind of thing I'm thinking about. So the whole structure for this version, what we're seeing here, I don't think it is going to look anything like the design of this one here. So this one that I did out of folded steel with the ears as part of the front panel. This is all a single piece of metal that's just laser cut and then folded. I don't think it's going to be like this. I think it's going to be more like a box with perhaps with detachable ear lugs, you know, like rack mount equipment typically has. So you have some screws that go in through the side to attach. They're basically like an L-shaped bracket, and you just screw it into the side. So they're detachable, which means you can use it wall mounted or something else if you prefer. You don't want to rack mount it. And the front panel will probably be a separate piece of aluminium. I'm not quite sure yet, this is going to get into a whole mechanical discussion that is way too long to get into right now. But I suspect that what will end up happening is that the front panel portion will be a separate piece of aluminium, and that means that when the other pieces are done, like the mounting ears, the cover, the internal, like the main box part of it, all of that sort of thing, that can be exactly the same for all the variations of the case, and the front panel is a thing that can vary. So I'm not quite sure how to achieve that yet from a mechanical point of view, but you've raised a very important point there, and we will get to the discussion of the mechanicals. And Andrew said, and drill a hole so the ears can be mounted facing down for wall mounting. Yeah, that is pretty common for rack gear. So the mounting holes on the ears, I've got racks full of rack gear in the garage. I could go and grab something and bring it in, but I won't bother. I'll just wave my hands instead. The way the ears are normally mounted is it's quite common to have 4 screws and they're in a square pattern, which means you can rotate the ear 90 degrees and screw it on, and then you can take the case and mount it against a wall and screw the ears straight into the wall. Yes. Cool. Now, back to here. It's now 12 and I haven't even looked at Discord yet, and there was stuff in Discord that I wanted to see. So people have been continuing this discussion since I've even looked at it, and let's go and look at Discord now because I want to see those images that James has posted. And if all of this discussion has been useful to you so far, this project seems interesting, please come along to Discord. There is, go away. There is this topic, universal rack controller in projects, and this is where all this discussion is going on. In fact, I've even put up my Keynote file I've shared via Dropbox. I don't know how that works. Now that I've edited it, I don't know if that points to the latest version or what the deal is. But if anyone wants to grab my Keynote file and start screwing around with it, then you can do that. You can make your own versions of mock-ups of the front panels and see how things will fit. All right, so what have we got here? So 32 port, hang on, let's maximize this so that we can see it a bit better. Oops. So this is James's 32 port LSC. That's right. One of the topics I was meant to talk about was why you can't fit the 8 port things onto the same mounting holes. Yeah, cool. Nice one. Someone needs to tell John about dark mode. No. Yeah. Okay. Nice. So as I said earlier, my original thing here was all eyeballed dimensions. None of this has been measured and it's not necessarily proportional. So when I created this, I was just trying to get the whole reason for doing this in Keynote was that I could put the connectors on there and then just quickly move them around and say, oh, should we have them here or should we have them here? And should they be in this order? And it only takes a few seconds to make changes. An accurate mechanical representation of the dimensions. But yeah, cool. So what else have we got? Universal I/O. Cool. So this one, there has been some discussion about the universal I/O board as well, which could go in here. And this is one of the issues with, so if we go back to my Keynote thing. So this board, the one that I use for the light switch controller, what I've done is put external 10K pull-ups on all of the I/O lines, and like they're hardware pull-ups, you can't turn them off. And I've got a 1K resistor in series with each of the data lines. And that 1K resistor is put there as a form of protection against damage to the I/O driver chips when it's basically a current limiting resistor. So it means that it minimizes the risk of damage. They can still be exposed to ESD and those sorts of things, but we've got I/O lines on here that are connected to long wires that wander around the house, and bad things can happen. So it's just a way of protection. So that means that you can only use the light switch controller board as inputs that are biased high and that you switch to ground to activate them. It means it's not generally useful as a universal I/O board, even though those MCP 23017s can be driven as both inputs and outputs. So one thing I've been thinking about doing was assembling versions of this board and just leaving off the 10K pull-ups and putting 0 ohm resistors in place of the 1K resistors. And what that would do is give you a bunch of I2C I/O drivers with the connections exposed here directly, nothing else interfering. You can use software pull-ups if you want, you can use them as inputs, you can use them as outputs, you can do whatever you like. But at the moment, that is one, because this board has been optimized for light switches, it's not really designed for that purpose. So this board, the universal I/O, is designed to avoid that problem, basically. Oh yeah, so Austin here is talking about an earlier suggestion of large hole with insertable blanking plate. Yep. Oh yeah, there's some software stuff that I will skip over for now. Oh, does the PDU have a battery backup? Oh, interesting. So yeah, there's a whole lot of discussion here that I will read through in a bit more detail later. Oh, this is interesting. So this is getting into something that I was thinking about but has not mentioned, which is mains powering these devices. So cool. Updated PDU by James. So what you could do is put an IEC lead on the back here going into an internal power supply. So you need a flat mains power supply that will fit within that 42 millimeter clearance or whatever it is that's within the case. Like the a 1 rack unit case, I can't remember the exact dimensions, it's like 44 point something millimeters, and I don't care about what it is in imperial measurements, millimeters are all that matter, minus the clearance of the thickness of the case and everything. So it's like just over 40 millimeters of vertical space that you've got inside the enclosure. So you could put a power supply in there, and in this case what James is doing is he's got XT60 connectors across the back and switchable outputs. So this is a way of being able to switch power to external things controlled by whatever logic board is in here. Dodgy said, just uploaded a picture to the universal rack controller to show aluminium front panel. Nice. Okay. Austin said, personally I'd stay away from having the IEC in the rack. Yeah, so there are certainly safety issues with this. In this particular case, this is a board which I think is designed to deliver a lot of power to some loads. And this is not something that I would feel comfortable building and selling, because it's getting into the realm of, if this kills someone, then I don't want to do that. But this is an interesting application. It is something that you could use the framework of the URC to build. Yep. Oh, James says each output gets monitored, and if it goes over current, it auto trips that output. Nice. Yeah. Be the project. There's a whole lot of discussion there about it, which I'm just skimming through for the first time. I haven't read this far down in the thing yet. Oh, SPI plus I2C for touchscreen. Interesting. All right. Thanks for posting that, Austin. I'm going to look at that. I'm going to catch up on all these messages and read things later. I'm not going to do it right here on the live stream while everybody else is watching too. Yeah, so this is a concept for another board with a, looks like an RJ, like an Ethernet connection on there going through a header. Yeah, interesting. So Austin said, this is a connector I have on my Pro Mega controller I plan to use in my rack. Also plan to use this for another project with a much larger SPI plus I2C touchscreen, hence the 10-pin IDC. Yes, that is... I hadn't actually thought of that. I was thinking of only taking SPI through to the display because it's an SPI display. But ultimately, if we do want to have some kind of a touch interface, maybe having those extra pins is useful. So that is, yeah, thanks Austin. That's an interesting way of thinking about it. And Dodgy said, okay, so this is Dodgy's post. A front plate like this on the ground sound, it comes with or without ears. Yeah, so in this, so what you're saying then is this can be rack mounted, is my guess. So it's got this aluminium front panel on it, and you can just put it inside a cabinet like this and it looks nice. Or you can screw mounting ears on the side and then put it into an equipment rack. Yeah. All right. Well, I think it is time that I listened to Virtual Peter, and we, oh, cool. Yeah, Long Flare is standing in for Peter. Scott said, he's a Mac user, what is a thing? Yes, okay, so let's go back to here for a moment. There was something else that we discussed on Discord down here. I was talking about other front panel designs, and I kind of like the idea of, yes, cable tie, someone did say lunch. I kind of like the idea of some kind of an artwork on the front of it that is continuous, so that if you've got multiple devices that are stacked, the artwork follows on from it. So it forms a pattern down the rack. Someone in the chat suggested artwork that is different on each one so that they form slices of a picture, and then when you put it in the rack, there's a picture in the rack. That would be really cool to do, but not very practical from a distribution point of view. All right, so, and I kind of like the look of this. Now this whole concept, when I was messing around with this yesterday, this was before Tinker stepped in and threw a spanner in the works. Mitchell says that's the way to sell quantity. Yeah, like buy the collection and then you get the picture. You need 10 of them at least. The full edition is 42 rack units. Yeah, Stephen W said add-on ears is quite a bit more fab work than permanent ears. It absolutely is. Instead of being a single piece of aluminium with 4 holes, it is multiple pieces of aluminium that need to be folded. They need 4 holes in them for the screws. The holes ideally should be countersunk. Then you need 4 holes in the side of the case. Those holes need to be threaded. So you need to supply the separate mounting tags plus the 4 screws plus the threaded holes. And you are absolutely right that it is more fab work than permanent ears. And these sorts of questions are things that we're going to come up against once we get to the next stage of this. So right now, what I'm doing, I need to wrap this up. 42U gets you a picture of a squirrel. Yes. Oh, long flare, 10 past lunch. You are right. I am kind of trying to wrap this up now. So, yeah, anyway, I kind of like the idea of making this a bit more colorful than just plain white. I do like the look of the white. I've got homemade things like this in my racks, which I painted white, and it does look quite cool in the rack having these like pure white devices. But I also do like the idea of having a bit more color in it. Now, it'll be a bit different, of course, because we've now got only the display on the left and these other connectors are over on the right. But anyway, oh, there is so much more I could talk about with this. We were talking yesterday in the Discord about doing artwork on this using either vinyl wrap So we could find someone that does vinyl stick-on stuff and then do custom artwork with that, or doing this with a UV cured ink printer. So there is a place that is only like 5 minutes from my house that has a big UV cured ink printer, and what I could do is have all of the enclosures just painted so they're blank, and then they can go into the UV cured printer to print all of the labels and logo and all of the other colorful stuff on top of it. Okay, so what I'm going to wrap up with is where I am right now is designing this. No, not that. That's going back too far in time. Designing this board down here on the right. I couldn't really make much more progress on this until we had some consensus on the layout. Now that we have talked this through over and over and over again in the Discord, I am really happy with how this has come out. The idea of the display on the left, Ethernet USB on the right, big blank spot in the middle. This now gives me confidence that I can go away and start, no, I want that. That I can now go away and actually start doing this PCB. So the next thing I'm going to do is the board that goes down in the right. Do I have it in my recent history? Yes, I do. I believe. Yes. So, as you can see, it's a big jumbled mess. So what we've got is not quite complete 3 sheets, but it's getting there. So first sheet is we've got the ESP32. I'm just going to use a Vroom 32 module because I'm lazy and it's really easy. We've got the USB-C connection on the front panel, USB to serial converter, auto reset, pull-ups on I2C. So just basic stuff on the first sheet. Second sheet, we've got a 5-volt regulator and a power auto switch. So this circuit is based on what's on things like the Ether 10 and the Arduino Uno, where power can either come from an external power supply, like a DC jack, or it can come from USB, and it prioritizes the DC power jack and isolates USB power if there is external power. DIY in the Ghetto said, how's the new M1? It's really, really cool. Well, you just saw that like opening Eagle and everything was quick. It's nice. It's really nice. So 3.3 volt power supply. We've got decoupling over here. Oh, I just stuck this in because I was looking at what header we need for the display. There's a temperature sensor, so an MCP 9808 I2C temperature sensor, which I've used on lots of projects recently. That's my current favorite temperature sensor. And on the third sheet, we've got the Ethernet interface. Now, this is an area where things might be a little bit controversial, but I think this is the way I'm going to do it. This part of the circuit is largely cribbed from the Ether Uno. So AP8C socket, we've got activity LEDs, power over Ethernet support, we've got a WISNet Ethernet controller. Now people might be asking, why not just use the onboard Ethernet that's in the ESP32? And that's a whole discussion I could get into. I'm not going to get into that right now. Okay, I'm going to draw the line there. Micro SD card slot, so there'll be a micro SD card on it. MAC address ROM, I'm probably going to drop this because we can probably just take the ROM out of the ESP32, Ethernet status LEDs, and that's it. So back to the board. As you can see, it is a big jumbled mess right now, but the general concept is that now that we've got the display over on the left, so what I'm going to do is this is not going to be mounted here. This is just dropped in here because I added it to the schematic for the purposes of getting the connector. So there is now not going to be, like, a whole lot of things are going to have to change. That is not going to be there anymore. We're going to have Ethernet down the front. So this is going to be down here somewhere. No, not Ethernet, USB. It's going to be down the front. So it's at the point now where I need to start taking this jumbled mess and turn it into something sensible. And ultimately end up with the board that will go down here, that will have connections for power coming in from the back. It'll have USB and Ethernet on the front, I2C header, a header for going across to the display, and after Austin's prompting about touch displays, I'm going to go and rethink how that is done. And yeah, so the result of all of that is very soon we should have this board ready to go. And the nice thing about doing this is that this is just a cable with some 3D printed mounts. Yes. Alrighty. I am going to call it because it is now 17 minutes past the hour, and it is time for all good folks to go and have lunch or breakfast or dinner or go back to sleep. If you are hang on, where's my cursor? If you are watching this now at after 2 o'clock in the morning. So I've really enjoyed the discussion in the Discord about the light switch controller morphing into the universal rack controller project, and having input from so many different people that have got different ideas about how it can be used makes it so much more valuable and flexible, and the end result is definitely going to be way better than if I had simply sat down on my own, thought about it, and then made what I thought was the correct thing. So thank you very much for everybody that's been contributing to this discussion. And if you think that the Universal Rack Controller project is something that would be useful to you, please come along, join Discord if you're not on it already, and have your say. So thank you very much. And maybe next Sunday I'll have the party poppers and we can do a, we can consider next Sunday to be my birthday live stream or something, if I get them set up in time. And hopefully by then I will have the awesome new monitor, so life will be good. Okay. Eleanor said it's 4 in the morning. Oh, yes. You're either up very late or very early. Either way, you need to sleep. Thanks everyone. Now, because I don't actually have my normal setup, how do I end this live stream? I think I click this button right here. So, all right. I'm going to sign off today with maybe a somewhat obscure reference. May your survival be long and your death be swift.